Hello everyone, welcome back to Security Architecture in Real World, the series under Secure Terminus. So most systems are designed very carefully. We define how users should access application, how services should communicate. We also define what is allowed, what is not. So from a architectural perspective, everything looks structured. But attackers don't follow your design. They create their own paths, right? When we design systems, we usually assume predictable behavior. User login through defined entry point, then application calls all the approved APIs. Access is granted based on intended use only. Everything is built around expected flows. And within these flows, security often works because we test it as well. But real environments, they don't behave that way. Attackers don't care about intended workflows at all. They look for small gaps and actually connect them. One weak permission here, one exposed token there, one trusted API call somewhere else. Individually, nothing looks critical, but together they actually form a path. That's your attack path. So an attack path is not a single vulnerability, right? It's a sequence, a series of small steps that lead from initial access to something valuable. It can be anything. It often crosses multiple systems, multiple teams, maybe multiple layers of your architecture sometimes. So no single step is dangerous enough to trigger a concern. Most organizations don't see these paths because they think in silos. The application team usually focuses on the application. The infrastructures team, they focus on your platform. Security looks at controls, every other control individually, but no one is looking at the entire flow. I mean the end-to-end flow. So the path exists, but it is invisible to people. Okay, let's take a very common setup: a web application, a backend API, a database to store, some internal services maybe, and a simple CI/CD pipeline. Nothing sounds unusual, right? Everything connected, just enough to function and serve your business need. Now, an attacker doesn't start with your most critical system. They start very small. Maybe one of your compromised endpoint, maybe a leaked credential, or maybe access to a low privileged application. So at this point, nothing critical is exposed. Once they are inside, they look around. They look for configuration files or environment variables or any deployment scripts, and they find something, maybe a token, API key, or even any stored credentials, right? It was never meant to be exposed, but it's there. Now they try to use it. They call an internal API. The API trusts the request because it comes from a known system. No extra validation, no strong verification, and just like that, they move to the next system. In the new system, permissions are broader. Maybe an IAM role is over permissive, maybe authorization checks are completely weak, or maybe your trust is completely inherited. Now they can access more than what was intended. They're not breaking anything, they're using what already exists. At this point, they actually reach their goal. When I say they, I'm talking about the attackers. Their goal can be your sensitive data, your critical systems, or just having a long term access as well. And if you look back, no single step actually looked serious, right? But the complete path, it was. This works because of implicit trust. System trust each other, APIs trust the internal calls, identities have more access than needed. And most importantly, no one is validating each step in this flow, the complete flow, what we're talking about. So, this is not just an operational gap. I'll say it's an architectural failure. There is no visibility into full attack path. Trust relationships are not very clearly defined. Controls are not aligned to how systems interact with each other. An attacker movement, maybe it was never tested. The architecture assumes safety without verifying it. That's what happened in our case currently, what we just discussed about. Now, if a good architecture, right? So, good architecture thinks a little different. It focuses on flows, not just the components. It maps how data and access move across the systems. It validates every other interaction and it actually reduces all the unnecessary trust. And it limits how far an attacker can move. That's very important here. So, practically, you don't need to redesign everything. Start by mapping a real access path. Identify where trust exists. Test how far your access can go, right? And mainly secure your credentials. Monitor behavior across systems. So it's not just the events, right? You have to monitor behavior across all the systems. Now, when you understand attack path, what we just discussed, right? There can be multiple type of paths like this. When you understand attack paths, first thing, you reduce the hidden risk, you detect movement very earlier, and you actually gain control over how your system interacts. That's very important. So, attacker don't break your architecture, they just use it. And the attack path they take are often the ones you never designed for. Think about it. Thank you.